Okay, welcome to part 4 of the pollution lecture. This part talks about CFCs and the ozone layer. I'm sure you've heard of CFCs before. CFCs are a specific kind of halocarbon, and we started making them in the 60s and 70s as propellants, as cleaners. They're also used as or they used to be used as refrigerants, like in air conditioners and refrigerators. And initially, we thought that CFCs were okay. They're very non reactive when they're down here in our level of the atmosphere. And so we thought that they were very safe to use. But we learned in the mid 80s that once CFCs get into the stratosphere, they're bad news. You don't need to be able to redraw this chemical reaction here or anything, but you do need to understand that once these CFCs or chlorofluorocarbons get into the stratosphere, they begin to break down ozone. If you just know the very basic part of that, that's enough to know. And so that means they're breaking down the good ozone in the stratosphere that's protecting us from UV radiation. And that's bad news. So once we figured out in the mid 80s that CFCs were an issue, and that there was an ozone hole that was forming, um, a lot of concern popped up, and we knew that something needed to be done. So what happened? Well, along comes an international treaty called the Montreal Protocol. This There was a large meeting of several countries that took place in Montreal, Canada, and they signed this international treaty. Basically, the countries that signed it said, we will stop, we will cut production of CFCs in half by 1998. Um, and a lot of countries were even much more aggressive about it and said by 1998, we will completely quit making CFCs. Um, and they added some other chemicals to the list too that were also known to be depleting the ozone layer. Um, the Montreal Protocol is now considered to be super duper successful. The ozone layer is repairing and kind of recovering on its own, and it's expected to be recovered fully by 2060. So the Montreal Protocol is used as basically one of the best models to show that if countries can come together and agree to tackle environmental problems together, that we really can see success. So make sure that you know the Montreal Protocol. It's definitely going to pop up on the AP exam, and know that it was put in place to regulate CFCs in order to repair the ozone hole. Um, Acid rain or acid deposition is also discussed in this chapter. This is also a global problem. And we call it acid precipitation because you can have more than just acid rain. Unfortunately, fog, snow even can be acidic. So that's why we call it acid precipitation. And you do need to know the basic chemical formula here. So the two things that we're most concerned about with acid rain are sulfur dioxide and nitric oxide, okay, that are released when we're burning fossil fuels. They're released during combustion. Once they're in the atmosphere, they're mixing with water and oxygen and making sulfuric acid and nitric acid. Okay, so those formulas aren't too terribly hard to remember. Um, Acid deposition or acid rain is certainly a concern for many, many reasons. There's a long list here. You don't need to know everything. You don't need to memorize everything on the list. But um, once you get a lot of acid precipitation in soil, um, basically you start to leach out those really good minerals out of your soil that your plants need. So it's really hard for plants to get the particular compounds out of the soil that they need. Your waterways can turn very acidic, obviously, when you have acid deposition. Plants um, tend to have a lot of issues with acid rain. It destroys their bark, it's harmful to their leaves, it's harmful to their root systems. And so they don't grow as well. And if they're having issues with their leaves and their bark, they they can't protect themselves against pests as well. Um, you also begin to see reduced diversity in forest systems that are seeing a lot of acid rain, because any organism that lives in or around the water, let's say frogs or any kind of amphibian, are going to be affected by acid rain or an acidic waterway. And that could lead to a trophic cascade where you have issues even farther down the food web. Um, this is a picture of Cleopatra's Needle. If you've ever been to Central Park, maybe you've seen Cleopatra's Needle. It sat in the desert in Egypt for a really long time and had all these cool hieroglyphics on it. It was given to the United States in order to repay a debt. And after being in Central Park for not very long at all, it had sat in the desert in Egypt forever and ever and ever and had all these beautiful hieroglyphics that stayed intact. It was moved to New York City, and now you can barely read the hieroglyphics on it. I visited it maybe 3 years ago, and it looks like a concrete pillar. You can't even see any of the hieroglyphics on it anymore. So acid rain can really erode stone structures and statues as well. How are we addressing acid rain? The Clean Air Act that was established in 1990 put a program in place that is another cap and trade program or an emissions trading program that allows for trading of sulfur dioxide pollutants. So companies are given rights to put a certain amount of sulfur dioxide into the atmosphere. They can buy more rights, they can sell their rights, they can trade rights. And that way, we can put a cap, we can put a limit on how much sulfur dioxide is being put into the atmosphere. The cap and trade program that was part of the Clean Air Act in 1990 has successfully reduced sulfur dioxide emissions by 67%. So again, another program that's been shown to be successful. And so when states are coming together and really working towards a common goal, we can see some success. This graph is showing too how our nitrogen oxides, when they are regulated, there have been restrictions put in place on them as well. We begin to see less acid rain. So you can see the pH of rain that was falling in 1990. You can see the pH of rain that was falling in 2014. And it's been reduced, again, because regulations were put in place to monitor those emissions. Indoor air quality is a concern as well. We spend a lot of time indoors now than we used to. Think of all the time that you spend indoors throughout a day. We spend much more time inside than we do outside. Developing countries have a special concern when it comes to indoor air pollution because a lot of them are still burning things, burning fuel wood, burning even things like dung in order to cook and heat inside their home. So there's certainly a concern there for indoor air pollution, and different steps can be taken to help reduce issues in developing countries with problems like this. I think we looked first semester at a solar stove, which would be an outdoor stove that uses the sun and doesn't require these folks who live in developing nations to have to burn wood inside their home in order to cook. Now, in industrialized nations, the problem is much different. Indoor air pollutants that we have problems with the most are tobacco smoke and radon. Tobacco smoke obviously comes from cigarettes. And remember, we've talked a bit about radon before. It's a radioactive gas that occurs naturally. So those are much different changes in industrialized nations than they are in developing nations.